Hello. In this video, we're going to be talking about some properties of exponents. Now, in talking about properties of exponents, this is going to let us use exponents in many different ways, and it'll lead right into our exponential functions uh, lessons. So the first one we're going to talk about is if we have something raised to an exponent times the same base raised to an exponent. This is like saying 2 to the third power times 2 to the second power. Now, when you raise something to an exponent, that means you're multiplying it by itself that many times. So 2 cubed is the same thing as 2 times 2 times 2. 2 squared is 2 times 2. So if we multiply these things together, we end up with 5 2's being multiplied together, or 2 to the fifth power. Now, a shortcut to get this, especially if you have really big exponents, is you can just add these exponents together. So if you multiply the bases, you add the exponents. So multiply the bases, add the exponents. I had a class one time that came up with cheers for some of these, so those would be forever ingrained in my brain and probably in theirs as well. All right, so that was for multiplying. If we're dividing like bases, so we have two bases that are the same and we're dividing them, that's kind of like saying we have 2 to the third power divided by 2 squared. I'll use the same numbers as an example here. So 2 cubed is 2 times 2 times 2, and 2 squared is 2 times 2. So if you remember, if you have a product on the top and the bottom, they're going to cancel each other out because they end up giving you just 1. All right, and so we're left with 2 to the first power because there's only one of them there. All right, so the shortcut here is we're going to take b and we're going to take the top number minus the bottom number. All right, so it's kind of the opposite of multiplying. So in multiplying like bases, you add the exponents. When you divide them, you do the opposite of adding, which is subtracting. Now sometimes when you do this, you'll end up with a negative exponent. So when you end up with a negative exponent, it's going to be a little bit different. So let's say we have some number that's not raised to an exponent. I'm just putting that there for the sake of you thinking that you don't just put it under 1. Times b to a negative exponent. Now, when this happens, you take whatever has the negative exponent and you move it to the other side of the fraction bar. The a doesn't have a negative exponent, so it stays where it's at. Whatever has the exponent or the negative exponent moves to the bottom, and it loses the negative. So, for example, I usually use a train analogy here, or a trip analogy. This negative is like a ticket. The M is like the luggage. So this is its ticket to the other side. Once it goes to the other side, it's used its ticket, so it doesn't have it anymore, but it still has its luggage. Okay, and this is the only thing with the ticket, so it's the only thing that moves to the other side. All right, something kind of along those lines. It's not negative, it's not positive, it's 0. Anything to the 0 power is 1. The way I usually explain that is I get a few different numbers. So let's say we have 3 cubed, 3 squared, 3 to the first power. I'm going to evaluate each of these and see if there's a pattern. So 3 cubed, that's 27. 3 squared is 9. 3 to the first power is 3. Each time that we look at these numbers, going from top to bottom, we're dividing by 3. So 3 to the 0 power is going to be 3 divided by 3, which is just 1. And this is the same thing with all numbers that you can raise to an exponent. All right. The next thing is if we have some base raised to an exponent and then raised to another exponent. So this is power to a power. That's like saying 2 cubed and then the whole thing squared. This means I'm multiplying 2 by itself 3 times, then I'm doing that 2 times. So that's going to be 2 times 2 times 2, that's 2 cubed, and I'm going to do that twice. 2 times 2 times 2. So I've got 6 2's in all. The shortcut for that is just multiplying these two things together. So when you have a power to a power, you multiply. That's b to the m times n. That's kind of a sloppy n there. All right, so power to a power, multiply. All right, and the last one here, we're not really going to use all that much in my class, but you probably should already know it. If you don't, if you have a rational exponent, so we have some number divided by another number as your exponent, what we're going to do here is we're going to change this to a radical. This bottom number is your index. The top number is your exponent. Now you can either write it like that, or you could write it like this, with the whole thing being raised to the m power. Either way, it ends up with the same thing. But just remember, your rational exponents is the same thing as taking the denominator as the root. All right, and that's the properties of exponents. Have a good one.